Okay, perfect. Thank you guys for joining. So yes, I think we can go ahead and start it off if you're ready.
Okay, sounds good. I'm going to talk about programming the Azure MXChip Internet of Things DevKit device. I'll get to what it is in a few minutes. Let's first talk about what's Azure Internet of Things. That's what this IoT stands for, Internet of Things, Azure's Internet of Things. This definition is focused on Azure specifically. It's a collection of Microsoft Cloud services that connect, monitor, and control IoT assets. The chip, let me tell you what I mean by chip. This is the Azure IoT chip. It's a chip that has a display. It has a temperature sensor, humidity sensor, pressure sensor, motion sensor. So that's what the MXChip is, the device. So let's go back to the definition. I just wanted to mention that so that you have more context on what I'm talking about. And probably some people that have experience with Arduino already know a lot about this topic. I consider myself a beginner. I don't have a lot of experience with this, but I was interested in checking out this device. Now, from Azure's perspective, an IoT solution is made up of one or more IoT devices that communicate with some backend services that are hosted in the cloud. In this case, Azure specifically provides a lot of cloud services to manage and analyze the output of the IoT assets. Again, an IoT asset is the chip that I'm talking about. So why would we need IoT devices? For example, if you have some real life scenarios for IoT devices are a mobile refrigeration truck that sends temperature every 5 minutes to an IoT hub to make some decisions when the temperature drops below a certain number, for example. Or a device monitoring a container in a chemical plant, sending an alert when the temperature exceeds a certain value. That could mean that an action needs to be taken by the operators at that chemical plant. Or for example, a control room in a refinery that could show the temperature. Hold on, let me mute everyone. Okay, everyone's muted now. Mute. Okay, cool. Sorry about that. A lot of noise in the background. As I was saying, a control room in a refinery may show the temperature, pressure, and flow volumes in a pipe, and that enables operators to monitor what's going in the facility, and again, take action if the temperature or the pressure goes above a certain amount. Now, this is an example of a real life a scenario of how the chips could be used. For example, you could have a DMX chip or other devices like a Raspberry Pi, and they can talk to an IoT hub. This is a Microsoft solution service that you need to create if you want to use your chip or connect your chip to Azure. The service is called IoT Hub. There are different pricing plans for this. And for example, you could stream analytics to data lake storage. Data lake storage is not IoT specific, but it can receive analytics from the chip, like temperature readings every hour or every minute. You can also send the data from the IoT Hub to time series insights, or you can use Event Grid to send notifications through logic apps, specifically emails, when something happens, when some reading from a sensor reaches a certain value, for example. Or you can also send the information to Cosmos DB. Now, the characteristics for an IoT device are these. They are usually embedded systems that require no human input. They're just sensing stuff, reading stuff from the environment. They can be deployed to remote locations. They are very small, so you can deploy them to places where physical access is difficult. They are usually sometimes only reachable through a backend solution. Because, well, in this case, the MXChip has an OLED display, has a display, but sometimes they don't have a display. And all the sensor information that they get, they send it to a backend solution. They also have limited power and processing resources. Since they're very small, you sometimes don't want to spend too much money on processing power. They also sometimes have intermittent or slow network connectivity. And they also use proprietary or custom libraries or protocols for them to function correctly. This is the pricing that I was talking about for the Azure IoT Hub. This is the standard tier. There's also a basic tier, but it didn't fit in the slide. So I just wanted to present the standard tier and so that you have an idea of how the pricing works. There's a free tier, and you can only send 8,000 messages a day, and the message size should be 0.5 kilobyte. If you send a message of 1 kilobyte, that counts as 2 messages, and you can send hundreds of thousands of messages. Now, Microsoft offers these IoT products. The one that we just reviewed is the Azure IT Hub. I'm not familiar with all of them, but for example, Azure Digital Twins lets you replicate your deployment of the IoT devices digitally, like in Azure. You can place the IoT devices in this solution, and you can visualize them here. And you also have Azure RTOS. Wait, no, sorry, Azure Windows for IoT. This is an operating system that you can deploy. For example, I believe you can deploy it in a Raspberry Pi. Yeah. Now, what is the Azure MXChip IoT DevKit? It's basically a chip. I showed you the screenshot, but this is kind of like what it is. You can kind of see it. It's very small. So what is it? It's a chip that has a microphone built in, a temperature sensor, a humidity sensor, a motion sensor. It has also Wi-Fi, a display, a pressure sensor, and headphones, the ability to connect headphones. And this is what it looks like. The headphone connector is here. This is the micro USB port, which allows you to power or connect this to a power outlet. There's a reset button. There are indicators for the Wi-Fi, for example here. And the sensors are at the bottom. The humidity is pressure, temperature, magnetometer, motion sensor. The RGB LED that you can control is also there. There are a couple of buttons that you use for configuration purposes. Now, in order to set it up, there are some very easy steps that you need to follow. First of all, you need to configure the Wi-Fi. It's very simple. You need to connect to the Wi-Fi of the device. And here in the Wi-Fi options for Windows. And then you connect to that Wi-Fi and type the password for your real Wi-Fi connection. You also need to install Arduino, the Arduino IDE, which you don't have to use. I use VS Code, but yeah, you can use Arduino to configure the chip. You need to install a couple of extensions in VS Code. There's an IoT extension. And you also need to install the ST-Link drivers. That's for connectivity between your USB port, because the chip gets connected to your laptop's USB port, from there to the chip itself. And there's a how do I navigate to this? Let me. Okay, there we go. There are tutorials on what you need to do to connect the device to your computer, and how to do everything that I said, like connecting the Wi-Fi and all of that with screenshots. And they show you very detailed steps on how to configure VS Code, how to install the extensions, and some other things that you need to do, like install the ST-Link drivers. They provide you with the website that you need to go to. And there are also tutorials on how to connect to the IoT Hub, all the steps that you need to follow from VS Code to create the IT Hub service in Azure. You can create it directly from VS Code, as long as you're already connected with your Azure account in VS Code. And at the end, there are sample projects so that you can play with them. So let's go back here. Now let's talk about what my side project was. Why did I buy the Azure MXChip? I like going outdoors to run, and sometimes here in the city in Monterey, the air quality is bad, and it's advised it's a good idea not to go outdoors and because the air quality is bad. There's a site that provides you with live information. I think there's a 1 hour delay, I think, or maybe 8 hours, something like that. Anyway, there's a small delay, and they provide you with the information on the air quality of the city. And red means really bad, orange means bad, yellow means acceptable, and green means good. And I usually just go outside to work out, run, when it's either green or yellow. So what I was doing before was every time I go outside, I go to this page and check the closest, what is this, like measure the closest map point to my address and see what the air quality is. Now, my initial approach was to connect the device to the IoT Hub in Azure and store air quality data there, and send an email when the air quality changed from either green or yellow to orange or red, meaning that I shouldn't go outdoors and work out. But there were some problems with that while I was developing that solution, and it was that I could potentially get emails. I was thinking about email notifications, like after hours, like maybe at night. And I can work around that. I can probably disable the email, sending emails at specific times. But then I thought that I could even be getting emails like when I was not even interested in going outdoors, like maybe sometime a specific day I was supposed to go and run outside, but maybe at the end I didn't want to go, but I would still get an email if for some reason the air quality was changing from good or acceptable to bad. So my final approach was to just pull air quality data using Wi-Fi connection and also pull the temperature, because during the winter, I also try not to go work out when it's very cold outside, and display this information in the display. That's what I was going to do. And this was the end result. This has better resolution, but this was an incomplete. This was work in progress. It says bad air quality in the display. And what this is doing is the device is connecting to this page. It's parsing, going to the section that I want, parsing it and checking the color, and it displays what the quality is of what the air quality is. And in the end, I included the temperature. It's T as in temperature. It's 20 degrees Celsius. And there's good quality in this specific scenario, which was yesterday. Now let's talk about the code. As I mentioned, I use VS Code for this. It's already configured. And you need to create an INO file. I believe this is an Arduino file. That's why the extension is INO. And the programming language that you use is C++. You don't have to learn C++. There's a lot of tutorials, and most of the code is already there. You just need to tweak it for what you need. But you don't need to learn a little about C++ and also about the libraries, because if you look at the include section, I'm including the RGB LED library. I'm also including the Wi-Fi library and an HTTP library. And this is for example, the HTTP library is for you to be able to connect to do HTTP requests. Now let's look at the code. It's very simple. I have some global variables, and the code is split into two methods. There's a setup, which happens only one time, and there's a loop, which, as you can imagine, it is continuously running. In the setup, what you do is that you initialize the serial connection, or well, I know what serial is, but I don't know how to call it. Serial is what allows you to display log messages here in VS Code. So you initialize it. However, I had a problem, and it was not only me. A lot of people talk about this online, that it's not possible to output serial messages here, and I wasn't able to do it either. But I left the code there. Then you init the screen, this screen right here. You have to init that. Then you init the Wi-Fi, which is somewhere over here. And then you init the sensors. Let's look at what init Wi-Fi does. This code is mostly copy-paste. I used an already existing solution to initialize the Wi-Fi. So all it does is calls the begin method on the Wi-Fi object. It makes sure that it's connected, that the output of the method is connected. And if it is, then you're good. Otherwise, it's going to print a message that there's no Wi-Fi. And the init sensor method, what it does is that it calls the init method on the sensors after initializing a couple of variables. By the way, I didn't say this, but let me know if there are any questions on this code. And this is all you have to do in the setup method. Now let's look at the loop method. What it does is that it retrieves the air quality data by going to this site and parsing it. And it just compares what the air quality is. There are already predefined ranges that tell you if it's bad quality or if it's acceptable quality or good quality. And what I do is that I change the display, the RGB LED, to a specific color to indicate if it's good or bad. Like when it's good, it's green. And if it's acceptable, it's yellow. And if you can see, I don't know if you can see that. Let me check because I'm not looking at my camera right now. But if you can see here, what does it say? It says bad quality. Bad quality, and it's supposed to be orange, but it doesn't really look like orange. But it says bad quality, and it also shows the temperature as 22 degrees. And by the way, the connector is very, the cable is not very large, so that's why I have trouble showing you what it says. And I just disconnected it by mistake. Anyway, going back to the code. Yeah, so I display, I parse the air quality, I retrieve the air quality, and then I read the temperature and display it, and I add a 1 hour delay before this happens again. You need to manually do the delay, otherwise this code is continuously running. Let's look at the air quality, get air quality method. Here, you need to instantiate an HTTP client class, and then you pass it URL, which in my case, the URL is the website. So you pass it the URL, you send the request, and then you have a response. And with that response, I do some string manipulation with index of, for example, I want to find my station. That's what they're called, actually, stations across the city. My station, and then once I find my station, I look for the concentration property for the station, and then I convert that to an integer by just doing string manipulation, doing substrings and index of, and in the end, I just need to delete the HTTP client for cleaning up purposes, and then I just return the air quality. It's very simple. And the get temperature, read temperature, is it? Read temperature. This is what it does. By the way, let me take a step back. My first approach was to pull the temperature from Google, but I came across an issue with doing a request through SSL, HTTPS. I haven't been able to figure out why it's not working. It has to do with the certificate. I need to prepare the code somehow for SSL requests, but that didn't work. And that was good because I ended up using the temperature sensor of the device, which was great. Otherwise, I should have just bought an Arduino chip and it could have done the same thing. So like I said, I'm using the temperature sensor, and I just call the temperature method. I pass a variable in which to store the temperature, and I return it. You can do very similar things to get the pressure or get the humidity and all the sensors that it has, which I already forgot, like temperature, humidity, motion, in case there's motion, or pressure. This is weather-related pressure. So going back to the code, as I was saying, I print in the screen. The first parameter is the line number. The screen has, I think, three lines, 0, 1, 2, and 3. And you indicate which line you want to use and the text you want to print. And then you call the RGB object and you set the color, red, green, and blue. And for the temperature, I use line 3. And I print a buffer, which is T, and then the temperature with 2 decimal places. And then, as I mentioned, there's a delay. Now, my future project that I have in mind is sending an email when my garage door is open more than 5 minutes, because it has happened to me that I forget to close the garage door. It has happened a couple of times, and it would be a good idea to know when that happens. There's a magnetometer here that I believe can tell you if, okay, so what I'm planning to do is put this on one side of there are 2 doors in my garage. So I'm planning to put this in one garage door and then put a magnet on the other one. So if it's closed, if the magnet is close to the device, it's going to tell me that it's closed, that the doors are closed. But if they are open or too far apart, that's going to tell me that the doors are open. And my plan is that if I can identify that's happening for more than 5 minutes, have that code in an email when that happens. And as you again, it's very small. And one thing is that I haven't been able to find like a cover for it, like in case it rains and I have it outdoors. I haven't been able to find a cover for this. Arduino has a lot of really nice covers, but my plan is probably to buy one for Arduino and see if it fits in this device. So it was really cool programming it and learning how it works. Are there any questions about this? I would be interested in knowing if somebody is an Arduino fan or is into programming Arduino chips.
Yeah, well, sounds super cool, that device. I mean, years ago, it could be like 1,000 separate things to build something like this. So, well, what the basic question? Where do you buy it?
Sorry, what's the question? Is that Moises?
Where do you? Yeah, thanks. Where do you buy it?
Oh, I bought it at Amazon. It's like $50 maybe. 1,200 pesos, something like that. They're not that cheap as you would expect.
No.
Yeah, but since they have a lot of sensors, that makes up for the price, and the fact that you already have the Wi-Fi libraries and the HTTP libraries that you can just call. Otherwise, I mean, I wouldn't know how to do an HTTP request directly in C++. So it was good that there was already an HTTP class that I could use. So Amazon, that's a question. It's you can get them at Amazon.
Nice. Yeah, no, that's super cool. Thank you.
Sure. Any other questions?
I have a question. Sorry.
Yeah, Octavio?
Yes, I guess it doesn't have an operating system, right? I mean, like the Raspberry that you have Linux there. I guess this doesn't have an operating system, or?
No, it doesn't have an operating system.
And how do you deploy the code? I mean, you're working on.
I forgot to mention that. Glad you brought it up. There's a button here that if you click it, let me open the console here. Let me clear this, and I'm going to. It's connected right now. I'm going to upload the code. If there are error, it's going to fail. If not, it's going to work correctly. It loads the configuration. It gives you details on what's happening, and if there's an error, it also gives you very detailed errors on whether a variable is not declared, or if you're trying to print a number, which is not possible, you need to print characters. It's very simple. And
okay. But in that case, you can only have one application at the time deployed, right?
Yes. Yeah, unless in the loop you do several stuff at the time. But yeah, it's only one application running. I guess that would be a disadvantage of the MXChip. Now, at the same time, I wonder if you could install an operating system here. I don't know if someone has tried that, but yeah, no operating system, Octavio.
Okay, thank you.
Mm-hmm. And yeah, in the end, it tells you that it's done uploading the file to the chip after doing a lot of checks and a lot of stuff going on over here. But everything worked and it got deployed. Okay, I think.
Question. You there, Rodolfo?
Yeah, Jesus.
Yeah, so quick question. I can, my assumption is that you can connect a air quality sensor too, right?
Yes, you could do that. If there's such thing.
Yeah, there's a lot. Well, I was going to ask you if you kind of investigated if there was one that you.
Okay. No, I didn't investigate. I wonder how you connect it, because this thing doesn't have connectors attached to it. There's only the USB port and the headphones port over here, but that's pretty much it. There's no way to connect something else. But I'm going to take a look at that. I'm curious now on how you would connect something to this. Well, there's some stuff here over here. It says 1, 2, 3 and ground. Maybe this is where it would go. Maybe you need to.
Yeah, probably there are inputs, or you can put them with input outputs or something like that.
Okay. Yeah, I'll take a look at that to see how that would work. Yeah, so no, I didn't investigate. To answer your question, I didn't investigate about an air quality sensor.
Cool. No, thanks, Rodolfo.
Okay, cool. That's all I have. Thanks everyone for attending.
Thank you, Rodolfo, for joining us.
Thank you, Rodolfo.
Thank you, Rodolfo.
Thank you.
Thank you.
Thank you.